Introduction. Plyboard is a wood-based panel that has aesthetic value and durability. It is made of a score of soft wood strips that are glued together. As for the study, coconut peat is used to mix with cement or ordinary Portland cement for plyboard fabrication among other reinforcement materials since coconut peat is the most well-known fibrous waste from the coconut cultivation. Every year, the world produces at least 30 million tons of coconut, which are abundant in coastal areas of tropical countries. Due to high lignin content, coconut fiber is very elastic. Several benefits that can be derived from coconut include, among others, the use of its trunk for interior building insulation. Only a few studies have looked on fabricating plyboards. Existing studies mainly focus on fabricating plyboard using materials like sawdust and banana peels, focuses on the moisture performance. They are also using forest waste, specifically dry leaves. However, this has not been a study of coconut peat as a material in plyboard given its availability in most farmland.
Statement of the problem. To develop plyboards from coconut peat or Cocos nucifera serves as the primary objective of this study and evaluate its physical and mechanical properties. Specifically, this study aimed to: number 1, fabricate plyboards from different mixture of coconut peat and ordinary Portland cement. Number 2, determine the physical properties of plyboards fabricated from different mixtures of coconut peat and ordinary Portland cement at a different pressing time, 5, 10, 15 hours in connection with the water absorption capacity. Number 3, determine if there is significant difference in the physical properties of plyboards fabricated from different mixtures of coconut peat and ordinary Portland cement at different pressing time. Number 4, determine the mechanical properties of plyboards fabricated from different mixture of coconut peat and ordinary Portland cement with a different pressing time in terms of modulus rupture. Methodology. In this chapter, the materials used in the fabrication of plyboards using coconut peat and Portland cement. The test methods conducted are discussed in detail. To develop plyboards from coconut peat serves as the primary objective of this study and evaluate its physical and mechanical properties of coconut peat plyboards as stated in the scope of the study. However, the other focus of the research is the potential of coconut peat to be implemented as a waste product in the construction field. Picture presented is our research flow. First is preparation of materials. Next is manual removing of coconut husk. Next is sieving of coconut fiber to remove the coconut peat. Next is mixing and fabricating of coconut plyboard. And next is curing for 28 days. Next is testing its two properties, which is the physical properties and mechanical properties. So under physical properties is the water absorption method, and in mechanical properties is the modulus rupture test.
Results and discussion. The table presented is actual results of two-way ANOVA that examine the effect of a different mixtures and pressing time on modulus rupture of plyboards. The analysis examined whether it has a statistically significant interaction between the effects of different mixtures and pressing time on modulus rupture of Coco plyboards. The pressing time and mixtures of coco peat and ordinary Portland cement rose, and their interaction the time of pressing and mixtures of coco peat and ordinary Portland cement rose have statistically significant effects on the dependent variable, modulus rupture. The table presents that there is a significant difference in the modulus rupture of plyboards across different mixtures of coco peat and ordinary Portland cement. Mixture 3 had the highest modulus rupture, while Mixture 1 had the lowest modulus rupture. The result shows positive in modulus rupture that does not correlate to the study of Happy's et al. 2018 that shows that the value of the maximum tensile stress and the modulus of rupture increased with the increase in the concentration of peat used. The value added in length and strain decreased with a decrease in concentration of coco peat used. The results also shows correlated to the study of Moncol et al. 2020. Findings show that the viscosities of asphalt mastic with a coconut peat and baggage fillers are relatively similar to those with limestone filler for all temperatures at 20% filler content.
The table showed the post-hoc analysis using 2K-SHD. The results show there is a significant difference in the modular rupture of Plyboards across different freezing time. So the highest modulus rupture was observed after 15 hours of pressing, while the lowest modulus rupture was observed after 5 hours of pressing. The result does not correlate also to the result of the study of Happy's et al. 2018, but correlates to the study of Moncol et al. 2020. That shows the ways natural fillers, including bagasse and coconut peat, give similar mastic viscosity to limestone filler and higher than granite filler, which shows less difference in the performance result.
Water absorption. The table presented is the result of two-way ANOVA that examined the effect of different mixtures and pressing time on the water absorption of plyboards. The analysis examined whether there is a statistically significant interaction between the effects of different mixtures and pressing time on the water absorption of plyboards. The pressing time and mixtures of coconut peat and ordinary Portland cement rose under interaction. The time of pressing and the mixtures of coconut peat and ordinary Portland cement rose have statistically significant effects on the dependent variable, which is the water absorption. The result shows there is a significant difference in the water absorption of plyboards across different mixtures of coconut peat and ordinary Portland cement. Mixture 3 had the highest water absorption, while Mixture 1 had the lowest water absorption. The results correlates to the study of Osgi Andek et al. 2019 that shows coconut peat incorporation affects water absorption capacity of mortars, enhances their physical properties, and decreases their unit weight. These effects become more significant by increasing amount of fibers and when alkali-treated core fibers are replaced with untreated ones. The table presented is the post-hoc analysis using 2K-HSD. The result shows there is a significant difference in the water absorption of plyboards across different mixture. The results correlates to the study of Osgi Andek et al. 2019. Important physical properties of cement composites prepared with fine aggregate and coco peat were investigated. As a result, incorporation affects water absorption capacity of mortars, enhances their physical properties, and decreases their unit weight. These effects become more significant by increasing amount of fibers and when alkali-treated core fibers are replaced with untreated ones. In the study also of Sasoy 2019 concluded that the lesser it absorbs the water, the less will be the volume of voids, and the more it will be considered as a durable brick.
Summary. The study developed and tested plyboards fabricated from mixtures of coco peat and ordinary Portland cement. The mixtures are considered are 0.02 is to 0.02 cubic meter, 0.02 is to 0.03 cubic meter, 0.02 is to 0.04 cubic meter, with 3 replicates and a pressing time of 5, 10, 15 hours. The properties of plyboards were determined in terms of physical properties. Water absorption capacity was observed, and in terms of mechanical properties of modulus of rupture was tested. A 3x3 factorial design was used in designing the experiment. The average water absorption at 5 hours pressing time is 12%, 15%, and 27% respectively. In 10 hours pressing time, the average water absorption is 10.55%, 21.6%, and 25.3% respectively. In 15 hours pressing time, the average of water absorption rate is 12.7%, 21.6%, and 25% respectively. In terms of modulus rupture, the average modulus rupture in different mixtures in 5 hours pressing time are 2.6, 1.7, and 1 MPa respectively. In 10 hours pressing time, the average modulus rupture are 2.8, 1.92, and 1.26 MPa respectively. In 15 hours pressing time, the average modulus rupture are 3.09, 2.3, and 1.29 MPa respectively. Conclusion. By comparing the properties of the different mixtures of cement and coco peat at different pressing time of the developed plyboards, the mixture of 0.02 is to 0.02 at 15 hours pressing time is the best ratio, since the ratio has the high modulus rupture and less water absorption that passes international threshold. The methods used to test the specimen were very effective in finding out the properties of the developed plyboards fabricated from coco peat and cement at the different pressing time, which shows that there is significantly different in terms of variation of ratio in terms of modulus rupture and water absorption capacity. The results shows positive results that coincide to the previous study that also uses coco peat. This entails that coco peat can produce eco-friendly materials, specifically plywood. Recommendation. Based on the results of the study, it is recommended that plyboards are developed by mixing coco peat as raw materials at 0.02 is to 0.02 cubic meter to cement mixture. It is also recommended that coco peat can be used in creating construction materials, specifically plyboards. Further, recommendations for the other researchers that using the universal testing machine must be used instead of hydraulic press in testing of modulus of rupture.